In this video, we'll discover render props, a pattern for building reusable components that allow you to share logic and state between components. We'll learn to implement this pattern using a custom render prop as well as React's built-in children prop. Let's begin. When building comprehensive applications, one of the biggest challenges is modularizing code so that it can be shared and reused. This is important to avoid redundancy and to prevent a mess that often ends up in large code bases. React is not opinionated and instead leverages time tested software design patterns and techniques to promote efficient coding practices. One of the key things when developing React apps is to write reusable code. In fact, we already do that when we build components. Components help us encapsulate state, behavior, and presentation, and they can be composed and reused. Similarly, when you want to write reusable and shared component logic, you can use the render props pattern. Quite simply, you create a component that encapsulates the logic that you're trying to modularize. This component implements a prop, which you can call render or virtually anything else that you may prefer. This special props value must be a function that returns a React element. This means you're free to implement your own render logic and hive off the brains of the component into a reusable component. Render props is really a pattern and not a React feature per se. For instance, you could build a component called fetch rates, which could take a currency symbol and internally fetch the rates as needed. The render prop can then be used as a function where we get this fetched rate and then implement our own render logic. Likewise, a storage adapter which could allow us to store and fetch data from a remote database. In this case, the mechanics of the database and the operations are all hived off in the storage component, and we could reuse this wherever needed. Here, our render prop is actually named client, so you can use whatever name you like really. This way, behavior, logic, and even state for a given feature could be hived off into a reusable unit. Let's see render props in action. We'll build a weather component that accepts a location and provides us with weather conditions, which we can then render as we please using render props. Begin by downloading, extracting, and setting up the project first. We'll be building this project purely using function components. Here you can see our core app component, which implements a single state property called location, which is set when the user types in a location name in the box here. We have set the default value of this location as Bengaluru. Once the weather result is fetched from an API, we want to render this structure here, which currently shows some hard-coded weather data. We'll be fetching actual weather data from a free API endpoint provided by weatherstack.com. So before doing anything, go to weatherstack.com and sign up for a free account. Once you have an account, log into the dashboard and you should get your API access key, which we'll need when we query the API. Copy this key and we'll paste it in a special file called .env, which I've already created in the root of this project. .env is a popular way to create and store environment variables and credentials. The Create React App based toolchain provides a built-in support for .env files. All you need to do is create a file named .env in the root of your application folder and create variables beginning with the word react_app, such as the one you see here. You can then set this to your API access key value. Do note that this is not a secure way to store sensitive data and should be used with extreme caution. Additionally, .env files should be kept out of version control systems such as Git to prevent accidental leakages of sensitive data and secrets. Alright, now we'll create a new component named weather in the components folder, and this will contain all the logic that is necessary to fetch weather data. I'll create a function component named weather, which brings in two props. The location prop will bring in a string as the name of the location, while the render prop is what we'll use to implement our render logic. We'll need to create a couple of state variables, so let's bring in the useState hook, which lets us plug in state features in a function component. We have used this hook before, so it should be somewhat familiar by now. The isLoading variable will be set to true when we are fetching weather data from the WeatherStack API and will be set to false when we are done. The error variable will be set to true if we face issues fetching weather data. For simplicity, we'll not store error information that the API provides, but we'll simply rely on a true or false instead. We'll then create the temperature variable to hold the current temperature that we get from the API, and we'll set a default value of 0 here. Likewise, conditions will be set to a blank array because we'll get an array of weather conditions like sunny or partly cloudy, for instance, and we want to store them here. We'll also get a URI to an icon depicting the current weather conditions, and finally, the place variable will be used to hold the name of the location and the country so it can be displayed properly on the UI. Once we have these state variables and their setter functions initialized, we'll create the fetch weather function, which accepts a location string and queries the WeatherStack API before updating state variables with the data. First up, we'll set isLoading to true to indicate that we are fetching data. This can be used to display a preloader graphic, for instance. I'll then use the fetch API to query the URI that you can see here. And we'll also fetch and pass the API access key using process.env.react_app_API_key. And finally, the location string. We'll then parse the result as JSON before consuming it. The result that we get from this API will contain two objects, namely current and location, from where we will get our data. So first, we'll extract the temperature, weather_descriptions, and weather_icons from the current property. The weather_descriptions is the array of conditions, and the weather_icons is also an array which contains a URI for an icon depicting the current weather conditions at the location. Likewise, we'll get a proper name of the location being searched and the country from the location property in the results. Once we have these, we can use our state setter functions to set the values to their respective state properties. For the weather_icons, we'll access the first and only entry in the array since we are fetching current weather conditions and we'll only get one icon. For the place variable, we'll compose the value using the name of the location and the country. Finally, since we've got the results successfully, we'll set error to false to remove any previously displayed error notices. In the catch handler, I'll set error to true should there be an error, and we'll also implement a finally which will run after the promise succeeds or fails eventually. Here, we'll set isLoading to false, signaling that our transaction with the API has finally come to an end. Now, we need to run the fetch weather function when this function loads for the first time and whenever the location prop value updates. This requires the use of the useEffect hook. We'll implement the useEffect hook where we'll simply check to see if the location prop has data, and if so, we'll run the fetch weather function passing in the data, and this will do the needful for us. But this function will currently be executed whenever something updates. So in effect, the app will endlessly keep querying the API until your app crashes. We can easily prevent this by passing in an array with the location prop reference like so. What we're saying here is that run fetch weather only when the value in the location prop changes and never otherwise. And finally, we come to the focus of this video, our render prop. Normally, I would have had a JSX template here, like a div or a structure of nodes that create a UI. You can do that, but instead, we'll return an invocation of our render prop passing in variables which we want to expose out of this component. Our consumer needs this data to display and consume. By using the render prop, we are offloading the render logic to the consumer. Alternatively, you could render part of the UI here using a JSX template and still include a render prop to offload a portion of the UI to the consuming component. Before we go back into app.js, notice something unique here. We have not imported React into our namespace. This is because I've not implemented any JSX in this component since we are using render props. If you're not using any JSX, then you don't need to have React in the namespace of a component. Alright, let's export this out and import it in our app.js file. Now remember, this is what we need to render when we get the results. You can hive this off into another function component, but I'll just keep it here for this example. I'll cut this and replace it with our weather component, where we'll pass in the location query string to the location prop. In effect, what we've done is hive off the logic, state and behavior that is needed for fetching weather data from a location. What we have kept with us is the render logic. So we'll implement our render prop, which accepts a function where we'll bring in all the properties that we have exposed. This function should return a React component or element. We'll now check to see if there isn't any error, and if not, we'll render our data. Otherwise, we'll render a text message that says there was an error fetching the weather. Instead of this, you could have a component that displays some animation or logs the error occurrence perhaps. If there isn't any error and we are good to display results, we'll check to see if isLoading is true, and if so, we'll display a message saying please wait. And if not, then we'll render our UI like so. All we need to do now is replace our static data with the actual data we've received in the render prop. Conditions is an array, so we'll use join to render a comma separated list if there is more than one condition text in the array. And that's it. Let's see if this works. You'll notice we have an error. The reason for this error is that our WeatherStack API access key is not available in our environment. This is because after editing the .env file, you need to terminate and restart your development server. Once I do that, my app works perfectly. And now if I type a location, I get the weather data as expected. As you saw in this example, we hived off all the logic that is necessary for us to fetch weather data into its own component, and we kept the render logic to ourselves so that it can be customized by the consumer as needed. You can also take a component that implements a render prop and compose it with some other function to enhance or add abilities. After all, we're just getting data in the render prop function. We can use it to render another component that further augments its abilities before ultimately rendering something using its own render prop. This allows you to declaratively compose together logic, which is quite an incredible and powerful ability. It should also be noted that the name of the prop doesn't need to be render. It could be anything that you wish, as long as it implements a function that returns a React component or an element. Another way of implementing render props is to use the children prop, which provides React components with access to components that are enclosed within a pair of opening and closing component instances. So as an example, instead of a prop named render, if we use children as the prop, we can use our weather component as shown here. The function is passed to the weather component as a child object using the children prop, which is a reserved prop in React. It is no surprise that render props are used extensively by several community-built React components and packages such as React Router and Reach Router, Downshift, and many more. There is another way to create reusable and shared logic boxes. Let's see what that is in the next video.